Hello, Accelerated Math 7-8 students. We are working still in Module 14, and today's lesson is Lesson 13. And Lesson 13 is called The Graph of a Linear Equation in Two Variables. Our goal for today we will learn what a linear equation looks like on a graph and why it looks the way it does. The question that I want you to be thinking about is, why does the linear equation look the way it does? Oh, well, that's interesting. Okay, so check this out. It says graph this line, 3x minus y equals 8 on the coordinate plane. Okay, so basically we have an equation, and I haven't really taught you how to graph these. But basically, what I would suggest that you do is you identify the values for x, then you determine the y that would make the sentence true. And so there are some specific values that I like to make sure that I show when I'm trying to figure out what a specific line looks like on a graph. And the parameters are this. I usually put a -1 for the value of x, a 0 for the value of x, a 1 for the value of x, a 2 for the value of x, and if I have room, a 3. Okay? And so basically the reasons why I choose those as my values of x is because if the line is continuous and it goes on forever in both directions, you want to see what it's going to look like when you go there. So you'll notice on this graph, however, that I don't have a -1. So I'll have to draw it in, but you'll see what will happen when we do this. Okay, so now I take my line that I have right here, and I say 3x minus y equals 8. And I already know the x value is -1, so I'm trying to figure out what the y value would be. So first thing that I want to do is I would like to turn this into slope-intercept form. So I'm going to add y to both sides. So I'm going to add y. That creates this is a 0 pair. And what I'm left with, I have 3x equals y plus 8. All right, but I'm still trying to turn it into slope-intercept form, which means that the y is by itself. So now I'm going to get y by itself by subtracting 8 from both sides. And so now I have 3x minus 8 equals y. So now I'm going to use this equation to help me determine what the y value would be if these are my x coordinates. So I'm going to take 3 times a -1 minus 8, and then I'm going to have y. So 3 times the -1 is -3. I remember the rule of subtracting, which is adding the opposite, equals y. So I have 3 negatives and 8 negatives, so I have 11 negatives altogether. So y would equal -11. Okay, so that means that this line right here is going to touch on this graph. If I had put the whole graph on there, I would go to the left one and down 11, and that's where the point on that graph would be. So now let's try if it was 0. So we're going to use the slope-intercept form equation. So I have 3 times 0 minus 8 equals y. So 3 times 0 is 0, minus 8 equals y. 0 minus 8 is still a -8. So y would be -8 in this one. Okay, and now we're going to try 1. So I have 3 times 1 minus 8 equals y. So 3 times 1 is 3, adding the opposite. So I know that now I have 3 positives and 8 negatives, so my answer would be -5 for my y. So this would be -5. So as you can see, we still haven't even gotten on the graph yet, but we'll get there. All right, so now let's try the next one, and it says 3 times 2 minus 8 equals y, and so we have 6 minus 8 equals y, and so remember that we can add the opposite, so now we have 6 positives and 8 negatives, and so I have -2 after my 0 pairs. So y would be a negative 2. And then my last point would be 3 times 3 minus 8 equals y. 3 times 3 is 9 minus 8. And so y has to equal 1 for this one. Okay, so now we have our ordered pairs that happen to be sitting right here. And again, so if I extend my graph down, which I'm going to have to zoom out so you guys can actually see this because I want you to see everything. So I'm making a smaller graph, or I'm making the full graph, okay? And this very first point says -1, comma, -11. So I'm going to go over here to -1, and then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So that's -11 right there. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. And so I'm going to go down to -11 at -1 and put my first dot. So there it is. Okay. My second dot is 0, -8. So 1, 2, 3, 4, 5, 6, 7, 8. That's -8 right there. And I have to go right on the y-intercept. It's working. Look right here. Y equals 3x minus 8. So this was our b. Remember? Slope-intercept is y equals mx plus b. And so this is our equation. We have y equals 3x minus 8. So look at where it crossed on the y-axis. Did it cross at the -8? Yes, it did. And so now our next one says over 1 and down to -5. So 1, 2, 3, 4, 5. Here's -5. And I was going over 1, and so I actually have to put my dot right on top of my -5 that I wrote. Okay, so then my next one says go over 2 and down 2, which is about right here. Okay, and then my last one says go over 3, and I'm going up 1. So it's here. Okay, does everybody see that? So those are each of the plotted points on the graph. And now I need to pull out something that I can use as a ruler so that I can make a straight line. And I just happen to have an index card, so that will work. So let's make a straight line right here. And if my graph paper was perfect, then it would look even better. But when you're drawing in your graph, sometimes it's not absolutely perfect. But let's take a look at it. Okay, so here's what you have to notice. If you go back to our information, the unit rate is 3. Where it crosses the y-intercept is at -8. So let's look at it. So it's telling us that for every 3, you're going to go up. So you're going to go up 1, 2, 3 over 1. So that means we're going up 3 over 1. Remember how we talked about this in class? So we're going to go up 3, 1, 2, 3. Aha, it's working. Over 1. So we went up 3 and over 1, right? Now let's check this one. 1, 2, 3. So we went up 3 over 1 again. So it's working. Up 3 over 1. Now we're going up 1, 2, 3. Aha, it worked again. Up 3 over 1. Okay, so this is our unit rate, and our unit rate tells us 3. So that means we go up 3, and then we go over 1, because all of unit rates, when you use them in this equation, need to be written as a fraction. So it means you're going up 3 and to the right 1. Now, the way the directions are formed are as if this was a -3, then that means we would go down 3. If this was a -1, that means we would go to the left 1. So that's how you figure out which way you're traveling. But this is positive, so that means that we have to go up and to the right, up and to the right. So our next points, if we kept going, we would go up 3. So 1, 2, 3, and over 1. Okay, and then up 3, 1, 2, 3, and over 1. See, my line's not straight because of my graph down here being off, but you're going to go up 3, 1, 2, 3, and over 1, and then you're going to go up 3, 1, 2, 3, and over 1, and then up 1, 1, 2, 3, and over 1, and so your point would go there. So that actually is where our line should have gone if I had not drawn freehand graph paper. So it doesn't look like a very straight line, but you'll see when you have graph paper. So the rule on this one is up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And when you have a linear equation, it is a straight line, and that's how you figure it out. Okay, so now this question that I drew on top of says, what is the shape of the graph? And the shape of the graph is a straight line. And it would be even more straight if I had had my graph paper all on there instead of me trying to freehand draw it. So a lot of fun stuff. We're moving on. We're moving into algebra. We're getting closer and closer to algebra, and this is definitely something you have to know. This form, again, to remind you, this form right here is standard form. And just as a reminder, this form down here is slope-intercept form, and we learned that in yesterday's lesson, so slope-intercept form. Okay, and that's what it's called. All right, so let's go back to our goal. Today we will learn what a linear equation looks like on a graph and why it looks the way that it does. It is a straight line because this x right here has an exponent of 1, and that's what makes it a straight line. Remember when we were learning about linear and nonlinear lines. Okay, so that's all we have in this lesson. I'll talk to you soon. Bye.